Hi, good morning to everyone, and good evening to some. Is my voice audible to all of you? All right, so should we start now? Great. All right, so before we start, do you have any questions? So, this is our fifth session. We have discussed basics of big data, and we have discussed HDFS, we have discussed the components of Hadoop, we have discussed the yarn, we have discussed MapReduce using streaming. We have discussed MapReduce as a general concept, and today we are going to discuss advanced MapReduce using Java, along with few more details about MapReduce, such as partitioner and combiner and data locality. All right, so yeah, this is something which we are going to discuss. And the one of the advanced concepts which we are going to discuss is input splits. It is going to take a little bit of a time to understand that. So yes. So have you been able to finish all those four problems? Because when I observed last time, there were only few people who have actually submitted the subjective problems. Yeah. Basraj, Kalyan, Manish. Okay. Yeah, Kalyan, I saw your work. Yeah, that's right. Okay. Okay. Basraj, we are not using Cloud Data. We are using Hortonwork. So, all right. So here we are. All right. So Basraj says that let's discuss few of the basic commands of Hadoop which we are going to use. All right. Is everybody in for it? Although we have discussed it in earlier, but we'll just go through it once more. All right. And all right. So the first command which we are going to use, okay, is your Hadoop command. Okay. Hadoop command have first argument jar and Hadoop FS. Okay, so under Hadoop jar you have another argument here. There are various other commands such as fs and most importantly try minus help. Okay, then there are command called fs, then there is a command called, there are so many commands actually. Let me just log in and show you right away. Is the screen clearly visible? Should I increase the font? Is my screen clearly visible? Can you see the fonts? All right. So, okay. So let's just try a few commands. Few commands. So the most important command is Hadoop. Okay. If you say Hadoop, it will show you that these are the main commands under Hadoop. So Hadoop FS, you can see FS. FS it runs a generic file system client, which means you can interact with HDFS. So if you have to interact with HDFS, you have to use Hadoop FS commands. Then if you want to check the version, then this one, then jar, and then there is other important command is distcp. Okay. So distcp is a command that basically is for the initial data movement generally. So when you are moving all of your data to to Hadoop HDFS, it is advisable to use, yeah, so it is advisable to use distcp. Okay, whenever you have to basically copy enormous amounts of data, because this CP itself takes care of copying the data in a to a very in a very efficient manner. All right. Now, next, other commands are general commands like class path shows where are the libraries and how it's going to pick up libraries and all of that. And this is for daemon log. So daemon log shows the log of each class. You don't need this generally. You can basically use the task tracker. Okay. And you can use the web interface. I'll show you that web interface. If you remember when we ran our streaming job, so it gave us a URL. If you go to that URL, that shows you the log of the service. All right. Now, here you can see that using FS, let's try with FS. So Hadoop FS minus help. Okay. So here you can see that there are so many commands, and out of this, these are few. Basically, these are the main commands. All right. So let me copy paste. That makes it a little more interesting. All right. So the most important commands are Hadoop FS, append to file. If you have to copy a local file and append it to some file which is already there on the file system, you on HDFS, you can use Hadoop FS. Okay. Say append to file. So this is the use case I'm showing you. Okay. This is the use case. Append to file. Note that this is case sensitive. and my local file, and then goes my remote file. Okay, so local file part1, say you have got part1 and part2 and part3. Now what append to file does is it basically keeps on appending the parts, this data to this file. And the benefit of this kind of approach is that in real time, alright, so the benefit of this kind of approach is when you have continuous stream of data being accumulated locally on each of the machines, and all of these machines want to push it to the same file, then it makes sense to use this kind of approach. Okay, so instead of again and again creating a new file, new metadata, and going again and again to the name node, you keep on appending to the same file. All right, so that's the use case. Second one is, if there is a remote file, you want to see the remote file, you can say fs Hadoop FS minus cat, and then you can say this is my file. So this will basically print to the screen whatever is there in the remote file. Okay, out of this, so out of all of these commands, the one which we are going to use frequently is cat. Then we are going to use frequently is copy to local, and copy from local. These are the important commands. Copy from local copies the file from local directory to the HDFS, and copy to local copies the files from remote directory to local directory. Okay, and when I say remote directory can be specified, remote as in HDFS directory, can be specified as absolute, meaning starting with slash, saying slash user slash student slash something. Otherwise, if you do not specify the if your path does not start with slash, it means you're trying to specify a relative folder. What does it mean by relative, and relative to what? Relative to your home folder on HDFS. Your home folder is slash user slash student if you are a student, and then you whatever path you declare that I want to copy my local file to this file, which is a slash b, which means we are trying to put our file in a folder called slash user slash student slash a slash b. All right, so let me again say, so how does it look? It also it looks like Hadoop FS copy from local and my file.txt into, we can say, slash user slash student slash my folder, whatever folder you give it a name, say my folder name is sgiri, and into this we are trying to copy. Alright, otherwise the same thing can also means these two commands are equivalent. In one, we are specifying the target HDFS directory as absolute location, and this one is relative. Alright, so everybody is clear about these two? Alright, in case of copy to local is opposite of copy from local, and it basically copies data from remote file to the local file. Okay, so I have a feeling, okay, Alright, so any questions so far? So whenever I have to make the library available to all the MapReduce, do I suppose to use this CP? Okay, interesting question. So the question here is, let me just put it here so that in the video recording it comes. So question here is that whenever I have to make a library available to all the MapReduce, do I suppose to use this CP? Can anybody answer this question? Anyone? Alright. So Basraj says that put the library in class path, and so no, it wouldn't happen that way. Okay. Alright. So let's go back a bit and see what we had looked at earlier. So here, if you remember, when we were executing our MapReduce in streaming, so if you remember our MapReduce case, where we were trying to run mycommand.sh. Now, my command is you can think of it as a library, or you can think of it as some file which we want it to be available on all the nodes. Alright? So Hadoop gives you an option called -file mycommand.sh. Okay? So what does this exactly do? So whenever we have to say to Hadoop that this command is not available already on the machines, please deploy it before you start running it. Okay. Had this command been like our normal, like reduce command, right? Reduce command is unique. Unique is everywhere available. That's a Unix command, and we know that our Hadoop is right now running on Unix. Then it could have been okay. We don't have to deploy unique per se. But mycommand.sh or any other library on which my command depends. So there is another file, another shell file which has my command part of the commands, and mycommand.sh is using that other shell file. Now, in those cases, we would like to deploy both of them, and that is when we will say file. Here we'll say files option. There is a files option here, and we'll say mycmd1.sh. So this is, you can think of this as my library, and this is okay. So okay, this way, this file will be made available to all the nodes who are going to run MapReduce. And how does it do it? So there is something called distributed cache. Okay, so anything which we want to make available to all the nodes before running our code or while running our MapReduce, we can put it in distributed cache. Okay, and generally a distributed cache is nothing but a common place where from which the data gets copied to each node before running the MapReduce. So all the small files which we want to be available on all the nodes, we put them on the distributed cache. Streaming, the streaming API provides you the mechanism to put this stuff in distributed cache by the way of -files. Similarly, In case of Java MapReduce, it basically provides a similar kind of model where you can put the data in that distributed cache. Alright, so distributed cache is basically a small amount of a place where you can put few MBs of data and it will be distributed to all the nodes and will be deleted after the work is done. After your MapReduce finishes, this whatever you had put in a distributed cache, it will vanish. All right. So that's a role of distributed cache. Now next is so although DistCP sounds like distributed cache, but it is not. DistCP is for it's like if you have to copy the 1,000 folders. So what you could do, you could use Hadoop FS. So what is DistCP? Let me say DistCP. So DistCP is equivalent of Hadoop FS, copy from local and your folder. Okay, this is my folder and this is HDFS folder. Okay, so this one is going to copy your local folder into HDFS folder. Alright, now what's the problem with this? Copy from local is not very well optimized. It is good only for copying a single file or a small single folder. But distcp does the same thing what Hadoop FS copy from local is doing, just that it is humongously distributed, meaning it will utilize all the nodes simultaneously to for even initial uploading of the files. Okay, so it utilizes a huge amount of um, I mean, it utilizes the whole cluster in order to move your data. It figures out that where are my files located and how do I transfer them properly. So all of those, that magic is the role of this CP. All right, good. Any other questions right now? So so that so we have gone through the basics of command here. One was this list of commands, and the second would be, so just go through this list of command Hadoop FS help that will give you exact details. And here copy from local CP and disk usage. You can see disk usage is for okay for checking the how much your HDFS is consumed, right? And I- we have already gone through this. Okay, so if there are any doubts and you want to get them cleared, drop us an email and we will schedule your one-on-one if you want. Okay, so this way you can basically interact with HDFS from here, and from the folder as I had shown you earlier, you can interact with HDFS from the browser itself. All right. So have you created your own folder? You can create your own folder here by using mkdir and your name. Hadoop FS mkdir and your name. My name, I have already created mine, so it will give an error. Okay. So fs minus ls, and I can say my folder will show me the list of files inside skd. Okay. Now let me just show you how to create a local file, and locally also try creating a folder. Okay, there is no okay. Alright, so locally also I've created a folder. Correct. SED unique are Unix command. Correct. And in Unix, every command is a file. They basically are programs. They basically are programs which basically contains the instructions. And similarly, you can also write your program and they will run. So here you can see, let me just create a file. Nano is not there, so I will have to use cat to write the data. Okay, now I'm writing something into this, which means inside cat, inside data test, we have written this, whatever we have typed earlier. Now we can copy this Hadoop FS minus copy from local, and we can say data test, and then we can say into my folder. Okay, Hadoop FS minus cat asgiri slash data test. Alright, so you can see this. Alright, so let me start now. So I think that should be clear, Basfaraz, that's good enough. Alright, is that good enough? So all of you, if you have a doubt about the basics, just drop us an email, or maybe you should schedule a one-on-one with one of our persons. Okay, so Kalyan's point is, okay, these are commands. These are commands used only for Hadoop streaming job, either in Mapper or Reducer, whereas Java MapReduce is Java code. Correct. That's correct. So for the difference between both is Hadoop jar, and in general when you run your Java code, so how do you do that is you write your Java code, compile it. After compiling your Java code, you create something called a jar. Jar is nothing but a bundle of the code, and you name it something whatever you want to say, and you create your jar, and then you run it. This way you run it, and you provide all the arguments which your program requires. Okay. Now this is the MapReduce. Okay. So some people thought that they will write some generic MapReduce. Okay, generic MapReduce. Okay, and which they started with, and there they provided that became the streaming. Okay, they created their jar, which is Hadoop streaming dot jar, which basically any argument you provide under mapper and reducer executes it internally. Okay, so basically Hadoop streaming is also a Java code internally, and basically it is a special kind of MapReduce for you, which takes argument as commands and runs it. Okay, acts as a bridge. All right, great. So first thing is that please code all your MapReduce problems, all five of those problems, and even the one which we left yesterday. I mean, in the previous session. Please code all of your MapReduce problems in your favorite language. Okay. You have six problems. Five were in one of the session, and one was in the last session. These are not too difficult to code. They will take maybe your 3 hours of time totally. Okay, these are very simple problems. So write the proper test cases, and the way to go about is all our student what they do is they create their they create their repository in GitHub. Okay, that if you create your repository in GitHub, that will also make it easier. So here on GitHub, so let me show you. GitHub is a open source repository where everybody creates their open source projects. This, and also it helps people to gain a lot of knowledge by going through the code, other people's code, and using that. Also, at GitHub repository, you basically, if you put there your put your code there and lot of people fork it, meaning copy it, it shows that these many people have forked it, meaning these many people have taken your code and trying to modify it. And the more people follow you, more people fork it, fork your code, the more popular and better rating you get. Okay, so I mean that means that your code is important and you are doing something really interesting. So this way you get popularity and visibility. This is the uh, new way of basically finding the talent. If the lots of companies basically look at your GitHub repository and see whether you are really doing good or you are not doing good. Okay, so here you can see that I have my already logged in, so I can create a new repository, a new organization, and then keep on committing the code there. So you can think of, if you have used your SVN repository earlier, so you can think of GitHub as global public GitHub repository where everyone can see your code, and not everyone can change your code, but they can see your code. All right. Create your repository and upload your code and let me know about the repository. This will also help me in reviewing your code very quickly. All right. All right. So has anybody attempted this problem? You are given a humongous text, and what you need to prepare is a big suggestions dictionary, meaning what to type after a particular word. So the moment user types happy, you give all the popular words after which have appeared in this text after happy. If somebody has typed how, you give the most popular recommendations after how. Okay. Alright, so Kalyan says, let me copy paste this.